Okay, well, we're going to take a look today at how to put a computer together. Get over to test out. Test out is something I use in my networking class. We used to use it in 151 and 152 when we really pushed for certifications in those, and we'll probably use it again to coincide with this Google product more. But right now, what I've got is a simulation up that basically wants me to build a computer. And so I'm going to add a computer, put in a motherboard, choose some off-the-shelf parts. And of course, again, you may look at this and think, well, this is not really doing it. But in some ways, this is actually better than doing it. And what I mean by that is you can take parts and try to put them together and then get to the end and go, oh, wow, that RAM doesn't fit, the computer doesn't turn on at all, and potentially screw up the computer. Usually when you're working for a place, if they do this kind of work, which these days they don't do much of, so this information is mostly for you if you want to build your own computer. Most places don't have you build computers and things. That's just, it's, you can just buy a better system cheaper from Dell and HP from a business standpoint. So in any case, they wouldn't usually have to do this, but in a lot of places where they do this, and there's still thousands of those places that do, they just have a bunch of parts sitting there. And you have to know enough about how the computer works together to put that stuff in. And again, that's stuff we cover in 151. So what I'm going to do is I'm going to come down here to motherboards. Whoops, first I need to actually get a system case, and it looks like they're only giving me one. And so I'm going to put that out here on the shelf. And the great thing about this particular product is I can look at the drive bays. I can take a look at where the motherboard's going to sit. You can see there's nothing there. I can take a look at the back of it and the front. And so it gives me quite a bit that I can do. So this is so far making this kind of easy for me because it's only got one case and one motherboard. So I guess that's the one I'm going to use. The details are nice though because it will actually show you all the specifications. So this is something you would get out of the user manual right here. So that's pretty nice. So I'm going to take that, and I do know that that goes right here, and that's kind of what they're testing over. Now see if I look at the back, I'll actually see ports in there, that kind of thing. Now I need to add in everything else, so if I want to, that's a pretty nice board. That's Asus Prime. Yeah, so it's pretty nice. Here's our RAM right there. This is where our CPU is going, and I can't physically do stuff with that. All as this is drop it in there. But again, that's what it's testing me on. It's like, hey, you're putting this system together. What do you put in there to make this work? Let's actually see if they put a power supply. Oh, I got a few power supplies. See, this is where they're going to test me more. If we look at the back, whoops, I forget scrolling actually makes that bigger and smaller, which is not what I want. I want to move up and down. So this is where the power supply goes, and you can see there's not one in there. So if I go back to where the motherboard sits, then that power supply should be down here at the bottom, is where it should be sitting. And yeah, sometimes they're up at the top. So look at the back again. They've got a fan up there, and there's no room for the power supply because that's where the ports are sitting. So the board's sitting up. Sometimes they shift that around, and the board is down here. That's actually the most common, that the board is down at the bottom and the power supply is up here at the top. But anyway, it doesn't really matter as long as we get it in the right place. So what does it want here? This is an ATX 20 pin. This is a 20 plus 4. So if we actually looked at, there's our details on this system, and we go to specifications. Let's maximize this thing. So the ATX power connection is a 24 pin, and it's got an 8 pin. So this is what it expects. It expects a 24 pin to be plugged in, and there'll be a spot for that. Looks like that's 2 right there. And then there'll actually be an 8 pin, and 4 of that will go someplace around here. There's going to be a plug-in, a CPU optional fan. Oh, that's the fan. And so we need at least a 24 pin. So if I drag this 20 pin over there, it's not going to work for us. Now this one actually is a 24 pin PCI. And so I'm going to try to dump this in there, and we're going to see if they give us an error. So that's dumped in the right place. And see, now it's like, okay, well, where do you put these connectors? Well, that connector, the 20 plus 4, goes right there. So if you have a board, this is exactly what it would need. And then here's the connector power supply that goes to the case for the CPU, I mean to the board for the CPU. If I can see it. That's the only bad thing, is navigating on this. Good thing though is that you can zoom in better than my eyes. All right, so here's some fans. See, that says CPU fan 2. And that says an A10 pump, actually, which we're probably not going to be using. And there is another fan. See, we got this. Got the six pin port right there. That's a 4 pin. So this one may not do for us what we need, because it's got a 4 pin and then it's got an 8 pin. Oh wait, that is an 8 pin. Sorry. And the great thing about this, actually, let me take that off. I should show you. Let me really zoom in on this. I always tell my students in 151, look at the ports, look at this detail. Not like, oh, look at this detail, that's awesome. That's not what I mean. But see how this one's square, this one's shaved, shaved, square, shaved, square, square, shaved. They've done that so that you can't plug in the wrong thing, so that you don't deliver the wrong power and blow something up and hurt it. So physically, I can connect this. So they're helping you out, and it's the same thing with the other as well. So even though I knew that that was a 24 pin and it was going to be 24, it actually makes sure that you can't reverse it and clip it backwards. You can try, but it won't go in because some of them are square, some of them have shaved corners. All right, so there's the power. Now normally, of course, you'd have to put screws in all of this, right? So let's take a look at the processors that we've got. We've got a few. Okay, now notice LGA 1366, 1151. This was what I was talking about. This is an AMD Phenom 2, so that's going back a ways. So what we need to do is find out what the socket is. So we need to look at the motherboard specifications again, the details of the motherboard. Where's our details? Can I scroll, please? There we are. So let's look at the specifications for the CPU. Number 3, it says over voltage jumper. So that's all that it says about that. So let's go down and see what it's got. It's scrolling way too fast. Okay. The motherboard comes with a surface mount LGA 1151. So that's an 8th gen Intel Core. So 1151, LGA stands for Land Grid Array. That means the pins are not on the CPU side, they're actually on the socket side. And so if we look real close here, I was hoping it was going to jump. These are all little tiny pins. Now, what they were thinking in doing this is that with the pins on these processors, the processors have to be stored in a way that the pins don't get bent. And so that's one of the reasons they were looking at it. And so what they did is, instead of putting the pins on the processor, they put the pins in here. Now the bad thing about that is see, you pull this open, see it's latched right here, so you pull that out, just push it with your thumb, and then you move that, right? So the lever comes all the way to the other side, not straight, but it comes up and over. And when it happens, this comes out from underneath this screw that's in there. So it's meant to clip right under that. And then this whole silver part flips up. And then it's got two little lines. See, this is the one we want because that's the 1151. But notice the Intel processors will have a little tiny gold corner and two lines. Two notches, not lines. And see, the notch on this one is different than the notch on that one. And this will have two plastic notches that stick in so you can't put the wrong processor in. But what I was getting to is if you're moving this processor over, and I've seen this happen with students, and they drop it and a corner hits in these pins, good luck, because those pins are probably busted now and it won't connect with the processor and won't work. So that's the scary part. It's actually very easy to get all the parts, but actually putting it together, you have to do a few things. And one of those is at this particular moment, do not drop that processor. Now the AMDs still kept the pin grid array, the PGA pin grid array. So they have pins on the processor and they have little tiny holes in here. And still, if you drop it, it's not going to be good. But usually it's easier to bend these pins back the way they need to be than these. That's usually once you drop it in there, it's dead. It'll ruin it. Anyway, so let's take, that's LGA 1151. I don't see any better processors. We only get these three. And we don't have to open that latch. That's the confusing thing. It'd be nice if it animated this and showed it fly upwards, and then you have to clamp it back down. This clamping process is really nice though, because it really holds that processor in place. They did a good job with that. So when you're putting your own system together, another thing you got to remember is you don't do it on a shag carpet. These components are very electrically damageable. You can really hurt them just with the static electricity that you can't feel leave your hands. And that's the thing. We're not talking about static electricity that will physically shock it. If you actually had static electricity and you that strong, boy, you really blew some things. The static electricity that'll kill this is 100 times smaller than that, especially the RAM. The RAM is very sensitive to static electricity. So if you're going to do this by yourself, either get yourself a static wrist strap, which costs you some money and you actually put it on your wrist. There's videos on YouTube about doing that. Or you take your shoes off, you take your socks off, you touch something metal and you do this not around carpet, right? You keep the static electricity out of you. All right, so that's our CPU. We put in our power supply. Let's not deal with the monitors yet. Let's deal with the RAM. So same thing with the RAM. This board is probably not going to take one of these because notice this notch and this one. See, they're in different places. These actually used to be harder. I'm really disappointed actually in test out here. I haven't seen this simulation in quite a while. Usually they give you like 6 different kinds of RAM and you had to figure out which one it was. They'd say put in the best, and so some of them were, you'd have 3 that are compatible with this board, but they wanted the best one, and so you had to understand that 2400 is better than 1800, DDR4 is better than DDR3, that kind of thing. Anyway, so let's select our motherboard again. Let's look at the details just to make sure. Specifications. Here's RAM, that's number 5. So it wants DDR4. That's what it wants. So we've only got one DDR4, and we're going to slide that in. And see, we've got all these different RAM slots. I always start with way over here, but it doesn't really matter. You'll notice that these are slightly different colors. And so I tell students that you really have to make sure what they mean. Not because you're going to damage anything, but a lot of times they'll line up the colors, meaning that since I put this into like a light gray or a darker gray and this one's black, then the next one should go in this gray. But on some boards, it'll actually tell you that no, you want it in gray and then black. And they'll change these colors. So sometimes they're blue and yellow. None of them are really standard. That kind of detail, again, is in the book, and it'll be under the RAM portion. this tells you what it is, right? So 5 says left to right dim 1, and so on. So it's telling you what the numbers are. And then on some of these, see, there's system memory. There we are. Here's our dual channel. All right, so if you got one DIMM, just install it and wherever you want, basically. If you got two DIMMs and you want to use dual channel operation, and that's a little faster. So technically, how much faster? Well, probably won't notice a difference, but you know, if I'm putting a system together, I'm going to make it as fast as I can, right? So for dual channel, you always need to install identical, the same brand, same speed, same chip type, DDR4 DIMMs in slots A1 and then B1. So it's wanting A1 and B1. So if we come back up here and we look at our 5, then left to right, so coming this direction, we have B1, then it goes to B2, and then A1 and 2. Right, so we want B1 and A1. So they're saying basically black and black or gray and gray is what they're talking about. So if I close this, if I'm putting 2 in, I would want it here first, and then I would take that other 8 gigs and I would want it here in the other black one. So I always mention that to students. That's not something that's always that way. You can't look at the colors and go, oh, I'll use the 2 black ones or I'll use the 2 gray ones because that's what that means. Sometimes it doesn't mean that. Sometimes it means I need to actually put one here. Oh boy, I just took the whole board out. There we go. Or one right here. Right, because it's electronics. It's what they want to do on the back side of this that's going to make it do what it says. Now, I don't know if it actually wanted 16 gigs in this. I actually didn't read that. I'm just kind of putting the stuff together. So let's move to hard drives. And I'm definitely going to go to a solid state. So let's zoom out a bit. That's way too far out. So I'm going to put the solid state down here because I should be able to mount it. Oh, it doesn't want me mounting it there. Okay, so I'll put it in here. Whoops, I got to switch. Sorry. Let's look at the drive bays. Let's see if we can use a drive bay. Nope, doesn't want that either. It's got to have a particular mounting point that it wants, although this is where it should go. Or maybe it won't allow that at all. We don't want a PATA. PATA is old, SATA is newer. So let's find out if they just don't. Yeah, they don't want us to use a solid state. So if I was building this, I would have put a solid state in here, connected that to SATA 0 or SATA 1. When you're dealing with SATA, they honestly will start with a 1 or a 0. You know, because in computers, sometimes 0 is the first number, right? So if we look for the SATA ports on this baby, they're all over here. It's got 6 SATAs, that's nice. And unfortunately, I can't see it all, can I? There's nothing telling me. So once again, I got to go to details. It's funny. Let's go to specifications. So, whoops. Ugh, scrolls way too fast. All right, so there's our SATAs 10. So this would be as if you're looking in the book. I'm telling you, this is exactly out of the book. So from top to bottom, left to right, that's where it starts SATA 1, which I bet you is totally false. I bet you this is SATA 1 down here. Anyway, they're saying that on the top, right? So this should be SATA 1, 2, 3, 4, 5, 6. And they can number them how they want, but they usually will have them labeled. They'll actually say SATA 1, and then this will say 2. And so we can't see that on this board. And so they're saying this is 1 and 2. It actually doesn't matter. You can plug in SATAs wherever the heck you want. But in these kinds of labs, they usually want it done in a certain way, as you can tell, because I'd be like, hey, I want this solid state. Give me the friggin' solid state. And it doesn't want me to do that. All right, so that's the hard drive, although it's not connected yet. Fans are already installed. See, and there's the connectors. And so let's assume that they want a SATA CD DVD, and I probably have gone far enough that you don't have to continue to watch this, so I'll put it on the top one, and there's the SATA connectors. And so I'm going to just kind of show you how the connectors go in, because I do have students that will just not do this right. So with SATA and I shouldn't say SATA, with any device that you're connecting to the main board that's going to be data related, and that's usually why you're connecting it, there's a data cable and then there's a power cable. And so this is the data cable for SATA. And the data cable for SATA has only got like 4 lines in here, and it's got a little tiny end that's notched, so you can't screw it up. Let's see if the details show it. Yeah. And so this comes down, so you can't screw it up, is what I'm saying. Let's look at the connector. Oh, it's not going to show us the other view. Zoom in. Yeah. This has got a little notch in it, so you can't flip it around and mess it up. It's very easy to slide in and slide out, so it shouldn't take any force. But that's the power cable. And so now we want, if we were going to plug in the power to it, we'd have to go to the power supply, because the power supply has got all the power connectors for different things. So here's a SATA, and so that SATA power, which is bigger and longer, is going to be connected there. And it's also got a notch in it, so you can't screw that up. And it's the same for the hard drive. And that is probably one of the most common mistakes that I have seen, is that students will plug in the power to the devices because the power is coming from this power supply unit, and then they don't plug in the data cable. They just don't plug it into the computer. And it's kind of like, how's the computer actually going to know what's going on, right? It's got to be plugged in. Otherwise, how does it get the data? So this thing is so touchy. Which I knew. Students complain about it all the time. It's like, that dang thing is just way too... All right, so I'm going to plug these data cables in, and then that's going to be the end of this little video. Whoops, that one's connected. This is the unconnected portion. It tells you right here. It tells you what it is. So that's the hard drive, and I'm going to plug it in on 1 because I like my hard drives on the first one. And then if we look at, we can either click the CD-ROM, so we can go to the drive bay and we can click on it. See, that's there. And we can see the data cable, and now it'll point it out for us. Or I could have found it down below. Oh. There we go. All right, this is the unconnected one. I'm going to plug it in right next to it, right there. See, now the CD has power, the hard drive has power. They both are connected to the motherboard for data, and that's awesome. The only other thing... No, it actually doesn't have a graphics card for us to plug in. And so I'm going to leave it there. That's just kind of an easier visual way to actually show you how to put that computer together. I figured, well, I could do a video of me putting one together, but that would take even longer because you'd have to see the screws and everything, and then I'd have to keep moving the monitor around and so on. If I exit out of this now, it's not complete. And so see, it's like, hey, you didn't do what you were supposed to do, right? I did install this, right? I did install that. And that's the way this thing usually works, is that you forget a couple of things and you can't, right? Can't do any of that stuff. I did not pass that. I'm going to have to do better. So in any case, that's the way you put those components into a computer. It's really not that hard to do. There's tons of videos out there on YouTube about how to do it if you want more detail. But honestly, if you want to do this kind of thing, let me know. You can definitely buy your own stuff and in 151 put it together, or actually just come into the lab. I'll let you use the lab and you can put it together there. If you have questions, please let me know.